Welcome back. Welcome back, everybody, to the last keynote of the conference. The next keynote and the last keynote of the conference. And as already mentioned in the morning, where we were listening to a keynote about platform engineering, building developer platforms, being company-wide developer and operations platforms, what it's all about and why one should or could consider building something like that. I promised you the next keynote, which really looks into a particular example. And here we are. What I learned is that the story of the New York Times is not about somebody said, we need a platform, and then we did this and this and that. It was more like analyzing the situation, trying to understand the situation, finding out what could help, and they ended up building what we called platformized engineering. And I'm really happy to announce the tech lead of the New York Times, Lesley Cordero, for that keynote. Please give a hand to Lesley. Thank you.
Awesome. Hello, everyone. Thank you for coming to my talk, and welcome to my talk on the role of platform engineering within the wider engineering organizations, and more specifically, how platform engineering can facilitate organizational sustainability. So before we continue, just a little bit about me. So I'm currently a staff engineer for the New York Times' operations engineering organization, and I'm focused on election readiness, because in the US it's an election year, and observability. And all of that sits under our wider engineering organization, our wider platform engineering organization. And so as someone who's responsible for the direction of my team and as an engineering leader across all of the Times, I spend a lot of my time thinking about the function of our platform and reliability engineering story and how it can facilitate success across all of the New York Times. And ultimately, what that looks like is coming from the perspective of enabling our department to work in a way that enables long-term organizational sustainability. And so I'll start off by talking about what I even mean when I say organizational sustainability. So more specifically, I define sustainability as the continuous practice of operating in a way that ensures short-term growth opportunities while ensuring long-term success. And so there's a lot to unpack here, so let's go ahead and do that. And so first, sustainability is a continuous practice. So even if we spend a lot of upfront time thinking about how to ensure long-term sustainability, circumstances change, and they often change quickly, especially with this year in tech, right? And so we're going to always need continuous avenues to ensure long-term success. Secondly, enabling short-term growth opportunities. And so sometimes the risky short-term growth opportunities are what lead to our long-term success, right? The emergence of bundles of tools, for example, is a really common thread now, and it has worked really well for some companies, including the Times. So if anyone here has used Wordle or New York Times Cooking or Wirecutter, et cetera, right? Yeah, we love those business decisions too, and that was because they were revolutionary for us. And so we don't want to give up the opportunities of those short-term growth opportunities, but putting on my reliability management hat, we also need to prepare for the risk of those short-term opportunities, which leads us to the component of enabling long-term success. So we frequently see companies take their core business for granted in the name of growth often, right? But for every successful growth opportunity, most opportunities do fail, unfortunately, right? And so preparation for this type of risk is essential. And so now that I've defined the goal, organizational sustainability, let's define the strategy, platform engineering. So as much as I hate repeating words on a slide, I'm going to do it if only for emphasis. So using my definition of platform engineering drives organizational sustainability by practicing sociotechnical principles that provide a community-driven support system for application developers using our standardized shared architecture. And so these three highlighted components form the basis of what it means to provide a platform. So one theme throughout this talk will be about how platform engineering can enable us to scale our organizations to enable the growth that our businesses often demand. And as part of that, we'll have to ask ourselves, like, at what point do we actually do platform engineering? Like, at what point is this actually necessary? And so we frequently talk about scaling software, but what does it also actually mean to scale an organization, right? And the answer is ultimately that our ability to scale our organization is directly tied to our ability to scale our software. And when we think about scaling our software, we have to be intentional about addressing the inevitable complexity that comes with that growth. And to address this complexity, we have to bring this intention into the architecture, into how our architecture can enable those needs. And so this is because complexity makes development so much harder, right? It makes it so much harder that we as a collective industry have evolved the ways that we even build applications, right? For example, the modular monolith has become increasingly popular as an architecture style, especially as an intermediate step towards distributed architecture patterns that enable us to work on and scale our applications. And so just like we've evolved the way that we build applications to embrace the new architectural patterns like microservices, we must also evolve the delivery strategies that we use to build these new architectural patterns. And so if these architectural patterns are a solution to the technical complexity of scaling our applications, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so to summarize it concisely, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. Sorry about that. So we'll spend the rest of this talk decomposing each of the components further, the principles that guide us, the community-driven support that enables application developers, and the architecture that we use and build along the way. So first, we have the principles that guide the rest of the platform. So having focused on reliability management, the principles that we'll review are heavily influenced by DevOps principles, since they take a strong consideration for both the technical and social components of what it means to develop and build and operate software. And so we'll head into those principles. So some of us might have heard of the COMS framework, which is basically a framework of principles that should be the core of DevOps organizations. It was created by Jez Humble. And now, while all 5 could be easily applicable, we're going to just focus on 3, specifically culture, automation, and measurement. So starting off with culture, the COMS framework tells us that DevOps drives a culture of continuous improvement and reduces silos by intentionally sharing knowledge and feedback. And the same is true here for platform engineering, but I'll talk about it more directly by putting in the context of community. So in DevOps, right, we often talk about breaking down silos, and the way that we bridge that is by sharing knowledge. And to share knowledge ultimately means to connect. And so connection and communication are going to be key for preventing the silos that otherwise would hinder our ability to make that continuous progress. And when we're talking about organizations, especially as our organizations grow, the most effective way is to manifest this culture of sharing is to think about how we can cultivate a strong community that fosters this culture at scale. Because ultimately, right, the opposite of isolation or silos is to be in community with other people. And the reason that this is so important is because more than anything else, learning is the most sustainable advantage. And so this quote is by Andrew Clay Schaefer, who is often known for being the co-founder of Puppet. And he recently said this in his talk about sociotechnical systems at DevOps Days Amsterdam. And the way I interpret it to mean is that because our industry is always changing, being able to keep up with this change is the biggest advantage that we can actually give ourselves. But to do that, right, learning needs to be a part of our DNA's, of our organization's DNA. And so while I totally agree with him, I'm going to modify this slightly to emphasize that communal learning is actually the most sustainable advantage. Because while our individual growth is important, if this knowledge isn't being shared intentionally, we risk introducing singular points of knowledge. And so like our technical systems, right, humans are not supposed to be 100% reliable. And so we shouldn't be putting anyone in the position to be singular points of failure or knowledge. Right? And this is how the silos are created. And this is ultimately how silos become an organizational pattern that hinders sustainability. And so in other words, communal learning is what provides us both the knowledge redundancies that we need to sustain both ourselves and the overall business. Next, we have automation, which improves our software delivery process by reducing human error or improving our efficiency and enabling faster delivery. This means thinking critically about the type of work that doesn't require business-specific knowledge and figuring out whether that work can be consolidated into software that's managed primarily by platform teams. And in this, right, we can reduce the required cognitive load that product engineers often have to indulge in by managing all aspects of their software. And the type of work that's important and can be consolidated away or automated away is work that's repeatable or manual, which is what SREs will often refer to as toil and what product engineers might refer to as like boilerplate code. And another aspect of platform engineering is how we should be explicit about improving efficiency by leaning into solutions built by third parties, whether through vendor solutions or open source ones. And the reason for this is because platform engineers need to reduce our own cognitive load and maintenance burden just as much as we do for product engineers. And lastly, we have measurement. So first, let's talk about the function of measurement, which is ultimately to have feedback loops for whether our work is actually having the intended impact. And these feedback loops consist of both qualitative and quantitative feedback loops for continuous improvement. And the way that this principle connects to sustainability is by eliminating time spent on work that doesn't ultimately lead to business goals. So for example, right, if we have a tool that we spent weeks on and it isn't actually serving our product engineering users, which is leading to lack of adoption, which is a metric that we often use in platform engineering, we've now invested time that could have just been directly serving our business domain, right? And so we end up missing the ultimate goal of building applications that age well with evolving product growth opportunities. And so in other words, these feedback loops keep us on the right path towards the continuous improvement that enables us to build new features while maintaining our existing software. So now that we've defined our principles, we'll shift over to talking about the support strategies for application developers integrating with our platform. So we'll speak to both scalable and flexible strategies and put it in context with the ways that we measure success. Give me a second. Yeah. Yeah. Cool.
Just try again.
Hello? How's that? Better? Oh, God, good. That was distracting me a lot, I'm not going to lie. All right, cool. Next section. So now we'll speak to both scalable and flexible strategies and put it in context in the ways that we measure success, consolidate efforts, and cultivate a culture that values sustainability. So the first is the most scalable strategy of all, which is to make building sustainable software easy. So we'll deep dive this more into the next section when we talk about our platform architecture. But to set the stage for that, let's remember from earlier that sustainable organizations are directly tied to their ability to build sustainable software. And I'm sure that we've all worked with software that clearly wasn't built with much foresight, right? This is usually what we refer to as tech debt. And tech debt is inevitable, right? But we can mitigate its risks somewhat by being intentional and strategic about when and where we inject tech debt. Right? Ultimately, tech debt should have a function, usually for the purposes of growth opportunities, and tools that aren't easy to integrate with are a type of technical debt that typically doesn't pay off in the long term. So it's especially our duty as platform engineers to build easy-to-use tools that minimize the time spent needing to support application developers. Now, that's not to say we shouldn't be willing to support them, right? In fact, the opposite is true. Just because platform engineering is supposed to make domain boundaries clearer and decouple product development from supportive tools doesn't mean that we get to stop talking to each other altogether, right? We still have to work with one another. And I know that as engineers, right, we often have an aversion to social interaction or whatever, but people are supposed to interact with people. And I think the pursuit to make everything self-service is often more harmful than it is helpful. So what we really need to do is be intentional about when the right time to support is and how we can leverage a culture of communal learning and support so that platform engineers are not the singular points of failure of knowledge that I mentioned earlier. And not only does this alleviate some tension on us, but it enables us to be community-driven in the way that we support product developers. And so we talked about measurement as a principle earlier. An important measurement of our effectiveness is the adoption of our platforms. And so what intention looks like here is ultimately defining the ways that we approach support and clearly and transparently communicating it to avoid mismatched expectations that will degrade trust between platform and product engineers. And in the interest of time, I'll only provide one example of this, which is to provide just an easy decision framework driven by status of your tool. So a common pitfall for platform engineers is to take on too much platform integration work. Like the last slide showed, there's room for that, especially in the early experimental modes. But that's not scalable and therefore not sustainable. And nor are we often even the right people to be doing that type of work because we don't have context for the services that we'll be integrating our tools with. And so a relatable example here might be like testing, right? Platform engineers can certainly create or recommend testing tools or methods, but we can't be the ones who are writing unit tests, right? That requires domain knowledge. And luckily, if we're doing our jobs right, the time that we save them by providing support frees up product engineering time to take on that application-specific work. And lastly, driving a sustainable culture. Sustainability doesn't just apply to software, right? It applies to people, and the two are very closely tied. And so referencing Accelerate, it talks about self-sustainability and the different types of burnout to look out for, whether that's physical or emotional, et cetera. And because platform engineering work naturally touches many, if not all, parts of our organizations, we have a unique opportunity to show what it looks like to operate in a way that achieves excellence without sacrificing people along the way. And our work is naturally collaborative and can impact so many parts of our organization, so we can drive a culture of intentionality forward with everything that we do. And lastly, we have our platform architecture, which is the architecture that platform engineers are building to support application development. And again, the function of this architecture ties directly to our first support strategy that we talked about, which is to make building sustainable software easy by consolidating efforts and cognitive load centrally. And so we already talked about our high-level principles, but now we're going to go into design principles for architecture. And the first is to embrace design-driven architecture as a core set of principles, right? Intentionality should be an important attribute of the way that we build technology and collaborate with one another. And this intention should manifest in the way that we design platform systems, whether that's to use abstraction or modularity to separate different functions and functional concerns. The principle can be broken down into many pieces, but we'll omit that for now because we'll talk about the design tensions and how to alleviate them in a few minutes. Secondly, our architecture should be complementary to those of our users. Now, that doesn't mean we shouldn't try to anticipate developer needs, right? There's a value in thinking about where our platform architecture might be headed. But to the last principle on intentional design, we need to design with the future in mind, not build for it immediately. Much in the same way that we might design a monolith application in a way that could enable us to decompose it to a distributed architecture in the future. So when we prioritize our work, we should be driven by the needs of application developers in our organization, whose architecture should be a reflection of our paying end users. And so that might lead to prioritizing and deprioritizing certain domains, whether that's CI/CD or observability or runtime language support. And so this is why we have an observability-focused team at the Times, for example, but I don't actually expect that to always be the case. It's just one of our most important needs now, but I see in the future potentially a reorg having us consolidate into other needs, whether that's CI/CD or cloud infrastructure. And within those domains and problems that we're trying to solve, we'll also need to build it in a way that's responsive to evolving architecture and developer needs. So for example, right, if we want to improve the runtime experience of developers, we should prioritize languages that are actually being used by them, not just the ones that we want to support first, even if we really do love Golang. Ultimately, right, we're not here to tell developers what to do, right? We're here to support them in what they need to do. And another reason this is so important is because our platform architecture can easily lead to what I call platform chaos. So I really hate this slide, right? And that's because we don't want that, right? We don't want to live in a world where we have 10 tools or platforms or whatever you want to call this for any given thing that we need to do, right? Unnecessary drift is painful, and we should try to avoid it. And overwhelming number of tools, especially custom ones, is not our goal, right? Tools are just enablers of our goal to build successful engineering organizations. And so instead, what we need to do is be managers of chaos. And the way that we do that is by aligning the components of our developer platform with specific domain use cases. And this enables us to design our platform so that we see the similar benefits of concrete separations of concerns that we see in end-user-facing applications. And this is where I'll take a moment to talk about a common pitfall that we see within platform engineering, which is that platform engineering is not equal to infrastructure platforms. And I think this is part of why there's a lot of naive conversations around DevOps being dead in lieu of platform engineering, because too many of us are operating on the assumption that the only shared platform that companies need is one that are limited to infrastructure. But, for example, right, we could also be thinking about how platforms can aid the service or feature development cycle during the actual development phase. That might mean having language runtime platforms that support development of standardized Node.js services, for example. And each of these can be decomposed even further. Though, again, tying to principle number 2, this decomposition should only happen if there's a genuine use case for it. So for example, right, if we decide to introduce a new standard language, then that's a good moment to decompose our runtime platform. In the infrastructure platform context, you might see that further broken up into domains like cloud infrastructure, CI/CD, and observability. And some techniques that we see in domain-driven design are the ones that we can reuse in this platform context too. Now, to complicate it even further, there are product platforms, which might refer to specific end-user product domain or core platform. You might see this as core services, depending on what your organizational structure is. And lastly, we have the principle of choosing boring technology. This ties back to when I spoke about not building tools from scratch. And we can prevent that by not leaning into every cutting opportunity, right? Some years ago, a blog post named Choose Boring Technologies by Dan McKinley went tech viral. And he talked about this idea of innovation tokens and how we need to be intentional about where we spend those. All right? And that's because engineers, we love to play with new tools. But every proof of concept shouldn't necessarily be making it to production. And I acknowledge this is super tempting, especially with orgs like the CNCF that are always building new standards and tools. But recency bias shouldn't be driving decision criteria. It should just be informing it. And one of the most seen as boring technologies are docs. This might be a controversial take, but too many internal developer platforms can be replaced by good best practices and standards documentation. And no, it's not as exciting, right? But it is still work that enables us to learn and mature how we build technology. And even if months or years later we decide we need to end up building a new tool anyway, it's still not wasted effort because it often actually ends up being a pretty good foundation for design and requirements gathering anyway. And so I mentioned earlier about some design tensions related to architecture best practices. So we're going to review those next, including the framework for how to address those 4 primary tensions. So first, we have what I think is the hardest tension to balance, standardization versus flexibility. So the shared nature of a developer platform is an awesome opportunity to reduce the risk of drift. But we have to hold that in tension with the flexibility that developers might need, especially as our organization grows and the number of technical needs grows with it. So for example, right now, my organization is facing the consequences of building tens of services with an opinionated framework that has since not aged well. And so now, not only do we have to revisit how we approach our runtime support, but we also have to reconcile the tech debt that manifested from this decision that we made years ago. And so reflecting on where we went wrong, but what we're doing now is to, 1, engage with our users more, and 2, it was an opportunity, it was a cutting-edge opportunity that we shouldn't have spent one of our innovation tokens on. And so I started off this talk by saying the opposite of isolation is community. And so now we're approaching it from the standpoint of driving standards with actual teams and our learning communities of practice. Next, we have the tension of simplicity and complexity. So as we respond to the evolving needs of our users, complexity is going to be harder to manage because the architecture that supports them is going to be subject to change. It might begin to use event-driven communication styles or begin embracing client-side rendered front ends, for example. And so this becomes another area that we need to be intentional about. Like tech debt, right? Complexity is inevitable, but we can compartmentalize it somewhat by making sure that the developer-facing interfaces are simple, which leads us to the most common source of complexity in software engineering, which is integrations. And so we know the common design principle of reducing coupling between services, right? And this applies to our work as well. Integrations are hard because avoiding coupling is incredibly difficult. Right? That's why a huge selling point for vendors is often their integrations. And that's so that we don't have to think about that. And so speaking of vendors, remember the automation principle from earlier. Even though I just spent some time talking through some design principles for building platforms, I'm also here to tell you, give yourself permission to not build at all. Right? The decision to build versus buy versus reuse should actually be our bread and butter. And deciding that we don't want to take on the work of building and maintaining a tool is a very valid one because, as one of my favorite mentors once said, every line of code that we write is a liability. And code isn't just the bread and butter of platform engineering, right? Research, design, and technical decisions are. And so engineering is a craft, and we should absolutely treat it as one. And so holding all these tensions in mind, let's talk through what I'll refer to as the platform framework. So this framework is a reusable framework with 4 pillars, and they allow us to enable, compartmentalize, and communicate the trade-offs of the tensions I just talked about. And so let's briefly review each of these pillars, and we'll provide some examples. So first, we have the parts of our architecture that provide standardization. So 2 examples of how we might do that is through templates or opinionated frameworks, like I mentioned for standardized node services, if that's our language of choice. Secondly, we have the parts of our architecture that provide more flexibility. So for example, right, we might design our framework to be more modular so that developers can pick and choose based off their context. Thirdly, we have the parts of our architecture that compartmentalize complexity through integrations, since the first 2 pillars reflect the simple interfaces that I mentioned earlier. And so these might be APIs that tie the first 2 pillars together, or plugins to front-end interfaces that developers use to provide visibility that they exist. And these tools are often not actually used directly by developers in their development, and are instead tools that we, as platform engineers, use to support developers in an automated way. So for example, the tools that pull our technologies together to support on-demand environments, right? All engineers will certainly use those environments, but the technical details of how we implement these should be abstracted away so that we can focus on product development. Lastly, we have the parts of our architecture that communicate our design and decisions along the way, whether that's API docs or decision records for when we decide to build, buy, or reuse. And so it might feel a little bit strange to have this be part of your architecture, but as I've emphasized throughout this talk, right, the touch points between platform and product engineers are essential. So documentation is the first obvious one, with support standards, with support channels as a complementary. There's also a potential need for automating certain aspects of support as we scale up the number of developers that we're supporting. So for example, our primary communication tool is Slack, and so integrations that consolidate questions and feedback centrally can enable us to have feedback loops that have really value for avoiding adoption issues, for example. And in the integrations pillar, I mentioned plugins as an example to provide visibility of what tools exist in our developer platform. And that's an essential question to answer because visibility is needed to drive adoption. And so we're going to answer that question of how to provide visibility into our architecture. So especially with the emergence of Backstage, which is an open source project by Spotify, developer portals have become a way to provide centralized visibility into the developer platform ecosystem of your company. And the concept of a developer platform portal is a compelling one, right? It tells the story of what it means to develop software at your company. And so by providing a unified view, not only does our platform become visible, it also facilitates visibility into any service that's using the portal, since it often comes with a service catalog. And integrations are a crucial part of developer portals, but because it's a centralized entry point, we do have to consider the risk of a singular point of failure. And this is why it embraces the idea of plugins, which are designed to be easily added or removed from the host application without that total coupling. And so in other words, as we saw in our principles, it provides similar benefits that we see as microservices by having concrete separations of concerns. So for the times, for example, we have a very concrete requirement that any plugin to Backstage must be able to be hosted on its own, regardless of whether Backstage itself is available or not. So now that we've covered some of the fundamentals, I'm going to move on to more concrete examples. And so in the spirit of showing that platform engineering is not just about infrastructure, we're going to talk through the story that I mentioned earlier of what it means to develop software at your company. And what that story ultimately looks like is around the feature development cycle. And so in the interest of time, I'm not going to go through each of these steps, but all you need to know is that this is the story that we're telling, the one that's around our feature development cycle. And the ones that are most relevant to platform engineers are often development, production readiness, and delivery stages. And so those are the ones that are going to be reflected in the next few slides. So this specific end-to-end use case we'll review is around the lifecycle of a service, focusing on the flow that reflects what it looks like to build a new service in an organization. So starting from the left side here, right, let's say as a product engineer, we're building a new backend service in an organization with a fairly mature platform, which is why we see some components here that I didn't maybe mention by name before. To get started, right, we enter our developer portal, integrated with an artifact manager, select a bundled standardized service template, enter details like your service name, and then an API integration that platform engineering teams own generates that service using an integration with GitHub. Now, you as a product developer are ready to develop your service. Depending on your development needs, you utilize even more modules or use framework features that are provided as well. From there, you'll continue to use GitHub, either directly, but now also through the developer portal until the PR process is done. And from there, as a product engineer, you enter the more delivery-focused part of your platform. And so that bundled service template that I mentioned that we use to generate a service also includes configuration templates that the CI stage can use to build, test, perform static code analysis, et cetera, so that we as product engineers no longer have to worry about building those things. We only have to worry about choosing good values and modifying a values.yaml file, for example. And since our portal includes a drone integration, we can easily gain visibility into each of these steps, which is especially useful for when they fail. And as a very best practice here, platform engineers should be very intentional about making it clear when CI/CD pipelines are failing because of our tools versus whether they're failing because of an application bug. And if the CI stage passes, right, a CI integration then pushes build artifacts that were generated in the CI stage, providing access to the rest of the stages in the pipeline. And again, the developer portal provides visibility through its artifact repo manager and drone integrations. These artifacts should be used during continuous deployment to perform things like infrastructure management, pre-production testing, et cetera. And so then, using GitHub or the portal integration, we move on to tasks related to release management, like approvals, release tagging, release documentation, et cetera. And so after successful testing and approvals, the service is successfully deployed to production using similar mechanisms as the CD stage, but with additional safeguards like automatic rollback features that platform engineering teams would own as well. And finally, we've concluded the delivery process and head into maintenance mode, which is supported by the tools that we provide to observe and monitor our systems, for example. So just breeze through that, but before I conclude, I wanted to bring us back to where we began. So to wrap this up, I've made a lot of parallels between DevOps and platform engineering throughout this talk, and I hope it's obvious how important DevOps has been to this discipline, right? Much in the same way that it has been for SRE. Our systems are complicated because people are complicated. And much like architecture design, this type of culture doesn't just happen, it requires intent. And the most compelling part of DevOps is ultimately the way that it transforms our culture to be one that fosters exactly that, intent. And so I started off this talk by saying platform engineering is a solution to building sustainable organizations, but perhaps the solution that we all really need is actually just intent. Thank you.
Thank you very much. We got time in case there's a question. Feel free to raise your hand, and I hand over the microphone to you.
Thank you. So going to the slides, plus from what we've seen in the industry, one thing we notice is that platform engineering team is generally a bottleneck. It's the same as when we used to have DevOps teams or we had ops teams only. So what does it become? Like, do you think there is a solution to that? Like, do we go into a platform engineering department, which is formed by 20-odd teams to support lots of teams? Or is this bottleneck just a fact of life?
I think it depends on what the cause of the bottleneck is.
Sorry, I was going to say the amount of responsibility, like if you see, we had 4.
So like the amount of ownership?
Yes.
Yeah. So that definitely happens at the times, and I've definitely seen it happen before. That's where you have to be aggressive about like ownership. Like if a team is owning, it has too many things that they're owning, then that means you need more headcount, or you have too much on, or you have too many tools that you're managing, for various reasons. So I think thinking about, what is it, Moore's Law, that says that your organization will reflect your architecture inevitably, right? I think being intentional about making sure that those are aligned at any given moment is usually what I've seen be affected for like mitigating like issues over ownership. Because I think for platform engineering, we do tend to have things just kind of thrown in us and being like, you own this now because more than like 2 teams use it or whatever. And so like from that's where you have to like be a little bit more aggressive, frankly, about service ownership, which is why having those good like relationships between product and platform engineering is so essential, because you have to make tough decisions like that. You're going to have to say no. Like being part of platform engineering, saying no is going to be just part of your job. And no one likes a bad guy, so that's why like it's intentional. That's why you have to be really intentional about making sure that you have built goodwill, that you have buy-in, et cetera. So that way you're not having platform teams that are overwhelmed with ownership.
Anybody else? Yeah.
So when you need to introduce a new platform to the community, and how do you foster adoption in the first step? Because a lot of things create friction, especially with developers. So how do you handle that?
Yeah. So for me specifically, I usually am. So especially as a tech lead, right? I'm always thinking about what's my 6-month strategy, my 1-year strategy, my 5-year strategy, et cetera. And so in the back of my mind, I kind of have a gauge of like, okay, this is where I would see us going in a year, in 2 years, et cetera. And so the 2+ years or even the 1+ year sort of what I call long-term bets, I start socializing them as soon as possible. So that way, when I'm finally ready to introduce the solution, it's not such a surprise. Like people already have it bought in, right? Like observability, one of the main reasons that it's a huge prioritization for the company now is because from day one, I started to sing sort of that song of like, this is something that's really, really important. And now it is the most important thing in our election readiness. So a lot of it's about like being proactive about one, getting people to be excited about the problem that you want to solve, because excitement is the hardest thing to get from developers, I've noticed. So yeah, if you can just get them like excited about solving this problem, like observability. I mean, I'm biased. I think it's exciting and whatnot, right? But like a lot of people don't. So it's been weird to see sort of that change in culture. A lot of it does end up kind of having to be sort of configuring your culture in a way that makes sure that it's valuing the right things. So that way, when you do ultimately introduce it, again, it's already got that built-in buy-in. And along that way, you probably actually learned a lot from your peers on like, oh, why it's like why like the gotchas that you might have missed, right? So yeah, I think about it very long-term because introducing random like platforms and whatnot, people usually don't respond to well.
It was very interesting because when you think long-term, what about on the budgets? What about the support you get for this? How do you manage this with expectations?
Yeah, so with respect to budget, that's why management is also part of the people that you want to make sure that you're getting buy-in as well. So I have really, frankly, I just have really good relationships with a lot of managers that make decisions. And so getting things like observability prioritized made it all the easier because they really, really, truly understood like why the problem was important. Maybe observability isn't our most important problem, but I was the one who was the best at communicating why it was.
But I was thinking also, like, what if the managers tell you, like, we need to reach that adoption stage at this time?
Yes, yes. So yeah, we have trouble with adoption. We've been having trouble with adoption up until recently. I guess, is your question about how to mitigate the issue or about, oh, okay.
Magic trick or hat.
Yeah. So that's why the feedback loops, I think, are really important because those will give you insight into like why
I was wondering how that loop, that feedback loop,
yes.
Do you manage this like in a formal way or do you manage this?
Yes, so some platform teams in my organization do versus some don't. I'm really informal, I'm very formal about it. Like I'll have spreadsheets or like Jira tickets or whatever that have like every single thing that I've learned from people. I very much treat it like a research problem. So again, in this, because a lot of it, some of the notes I have down sort of written in our different feedback loops might never go anywhere, but it's been really easy to like identify trends and whatnot that way. And then that'll help you sort of debug like the adoption issues and whatnot.
That's great, thank you.
Any more questions? No? Then I would say let's give another loud applause to Lesley Cordero. Thank you so much.
Yeah.
Almost time to say goodbye. I know you're spending the afternoon here, and lots of you also booked workshops for tomorrow or in 2 days. This is the last day, the last keynote of the DevOps and Serverless conferences, and I'd like to say thank you for joining us on behalf of the DevMio team. Again, please have a look to the app. Let's stay in contact through that. And please do not forget to rate all the sessions and all the overall conference. Give us your feedbacks, please, through the app, because we all want to learn and to improve over time, guided through your feedbacks. And let's just say thank you and enjoy the afternoon and enjoy the rest of the conference and have safe travels home. Thank you so much.